Kenny is playing on the mall escalator. And let me tell you, you probably shouldn't play on the mall escalator, especially when it's moving. And here it is moving, since Kenny can run the up the down escalator, and that basically means like you know how like in a mall there's like an escalator that goes up and goes down, and he can run up that escalator that goes down, or against that escalator for in 30 seconds. He can run up the down escalator in 30 seconds, and it takes him 6 seconds to run up the up escalator. How many seconds would it take Kenny to run up the flight of stairs that is in between the escalators? Now in this problem, it looks like, well, we want the flight of stairs, but we're only given stuff that's about the escalator. So how do we solve this problem? Well, the point is, if the flight of stairs is in between the escalators, well, doesn't that mean the flight of stairs is the exact same distance as the escalators? Well, if that's true, basically, in that case, well, the stairs is just the escalators not moving, right? Since an escalators are just basically like moving stair-shaped shapes. So yeah, so this is problem actually solvable, and well, in this problem, we can also see that using our other pieces of information, that when Kenny is running up that down escalator, well, his speed, if his running speed is k, which is just k is running across flat ground, just regular running speed, and then e is the escalator speed, which is like the down escalator speed, of just going down. And well, that means basically, well, the escalator is moving down, which is the opposite way of Kenny's moving direction, which means you can subtract these two speeds, and that gives us our new running up the down escalator speed. And we also know that this speed, this k minus e speed, we're also given that in numbers, which is up here. Since we know that in one flight, you can run one flight of this down escalator in 30 seconds. And we obviously can't deal with the unit 30 seconds, so we convert to minutes. Or in other words, you can run 2 flights of that escalator, 2 flights per minute. So if that's a down escalator, well, we can do the same thing, a little weird, same thing with the up escalator. I don't know what just happened. And the same thing here happens. If we have our 2 speeds, and now instead of the escalator going against Kenny is running up the up escalator. So the escalator is now helping Kenny, or in other words, we can add these 2 speeds. And see, again, we can't deal with the unit 2 seconds, so 6 seconds. So we can convert to minutes, or multiplying by 10, we have 1 times 10, which is 10 flights per minute. And well, if we just want running up the escalator that's not moving, the not moving escalator, well, that means you don't want the e at all, since e isn't doing anything, since e is the escalator and there's no escalator now. So you just want k. Well, if you just want k, well, if we have a positive e and we have a negative e, both of which you don't want, then we can simply add these 2 equations to each other. So instead of positive e, negative e, they can cancel out. Since now there's a big space, we just have k plus k, 2k, equals 12 flights per minute. 10 plus 2, 12 flights per minute. So simply dividing by 2, then we get k. He can run at a constant speed of 6 flights per minute. So if you want how many seconds would it take Kenny to run up the flight of stairs, well, if we know his speed, that means we can run 6 flights per minute. And if you want to run up 1 flight, and the flight of stairs, you can run 1 flight. You can divide by 6 to see that in 1 flight, you can run in 10 seconds.